Hi, this video is focused on part 2 of Domain 1 Cloud Reference Architecture. Please subscribe the channel and enable bell icon if not yet done. Also, please share the link with the aspiring candidates in your organization or in your network. So cryptography and the key management, these are very essential part of any cloud to protect the data. Evaluate the need for any cryptography for your cloud-based data and system. You should be carefully examining the type of data that you are securing, the threats to that data, and any regulatory or any contractual requirements related to securing the data. There are different stages that we have for any data. While the data is being stored at rest, data while it is being transferred from here to there, so data in transit, data in use, when the data is exactly being processed for for any modification or for any processing or etc. Some CSPs, the cloud security providers, cloud service providers, enables the encryption by default, and some are not. So we really need to take care of those aspects while we are facing any such question related to that. And this requires the various level of configurations to enable when it is being offered by default by any service provider. As a cloud security professional, make sure that you refer to the cloud service provider's product configuration guide to understand what's already done and what is your responsibility. So when we talk about the data in transit, this is especially we talk about when the data is actually in motion. It is being transferred from one place to another, and the security controls for this state is actually the TLS. For example, if you are accessing the web or you're using the REST APIs, then of course it is the HTTPS protocol, and of course the VPN is another control to protect the data while it is in transit. Data in use. What does it mean? It means any data which is there in the RAM or cache for some kind of processing. So that is the data in use. This is very tricky situation. It is not easy to protect the data while it is in use, and the challenge here is that the data can be processed only in the unencrypted form. So from the exam point of view, you may be tested for such questions, that how to protect the data while it is in use. So homomorphic encryption is the one which can be used while the data is in use. The key management aspects here, this is very important. If you have to protect your cryptographic keys, because any data which you try to protect while it is at rest, and while it is in transit, while it is in use, but one thing is very important, is the key, which is very important to store, to protect somewhere, somewhere in the strong mechanism of the cryptographic protection that is required to manage the keys. So two different ways here: remote KMS and the client side KMS. And also the managing with the key lifecycle. So key management is primarily, by the definition, it is managing with the key lifecycle cryptographically, starting from the generation to the decommissioning of those keys. Any single person should never handle the encryption, entire encryption. For example, somebody who is the key custodian should not have access to the data. So that is very important. Encryption and separation of the duty should always go hand in hand. Key management should be separated from the cloud service provider. um, The important aspect here is that there are various cloud service providers where they offer the hostage of the data, and they offer the encryption services, and they offer the key management services. But one thing you need to remember is that the key management should be separated from the cloud service provider. Few more important point here are the data owner should be responsible for the encryption. So if you face any such kind of question in the exam, remember that any data owner, he should be responsible for the encryption controls, control and manage the key management processes, storage location of the encryption keys. And it is very important to consider to segregate or to isolate both the domains where the data resides and where the key resides. It is always preferable to keep the keys isolated from there. The remote KMS, it is a remote key management service that is owned, operated, and maintained on premise by the customer. This configuration gives the customer complete control, starting from the generation to the decommissioning of those keys. While on the client side KMS, this is provided by the cloud service provider, but the customer generates, holds, and manage the keys. That is the client side KMS again gives the control. Gives the customer a great deal of control over their key management, but ensures the better integration with the cloud environment. And one more important aspect is in the remote KMS, it is always always a challenge to maintain the connectivity between the cloud and the on-premise. While on the client side KMS, um, we have this leverage that it is easy to integrate with the cloud environment, and the availability is not really the challenge. In software as a service, in SaaS model, usually this is the um, this is actually used for the SaaS model, because in there you just need to protect the data, and for that you need the client side KMS. So this is preferable there. There are different appliances that can be used for managing the keys. For example, the hardware security module. This is HSM, and there are virtual key managers. So different appliances which can be used to manage the keys. Cloud service capabilities here. There are different capabilities that are being offered as a service by the cloud service providers: infrastructure service capabilities, platform service capabilities, software service capabilities. We will talk about there in the different service models in detail. So here, this is the cloud service categories that are being offered by the different cloud service providers. Starting from the underlying control, which is the IaaS, infrastructure as a service. So what we offer here is the compute, storage, and network capabilities, which are being used by the system architects, network architects, to actually design these resources, and align in terms of the organization cybersecurity policies, and the needs, and to mitigate those risks. Who uses these? This is basically the platform for system and network architects by the system architect, and the network architects. So customer has more and more control here at IaaS level. When we talk about the responsibility, so the consumer has the responsibility, or the cloud customer has the responsibility of OS, software, and host firewall, for example, while the cloud service provider is responsible for storage, network, and processing power. So, what are the benefits of the IaaS? So, in terms of the cost, we have benefit. You don't need to spend money on buying and managing the hardware as as the need for additional resources grow. In addition, the customer also benefit from the cloud provider paying for and managing the physical security for the data center. You don't need to worry about the space, power, etc. And the different things in the data center that are on the cloud service provider. And the availability and reliability, this is infrastructure as a service that provides a customer with the load balancing and redundancy across the vast infrastructure. We have scalability with the IaaS service model. Additional resources can be procured, provisioned, and expanded quickly and with the ease to support growing demand. Whereas on-premise solution would require a lot of time, a lot of money to purchase, and to set up those servers. That is the benefit of IaaS. When we move up to the platform as a service, so who uses these platform as a service? Basically, this is the playground for the developers. This offers the platform for development. It provides the OS. It provides the platform for object storage, etc. And the application developers are the primary user of the platform as a service. Customer has the lesser control on PaaS, while in terms of the responsibilities, the customer is responsible for application configuration and the data. The cloud service provider is responsible for infrastructure, network storage, and operating systems. So that is the overall responsibility in PaaS. It sits on top of IaaS layer. Some features are inherited from the infrastructure as a service, and some are unique to PaaS. In terms of cost, similar to infrastructure as a service, the PaaS service category offers the cost saving because application developers pay only for system and resources they use. The customer progress through the development cycle. They can scale up or down with ease and without incurring unnecessary cost. Flexibility, the developer receives a lot of a great deal of flexibility during their application development lifecycle when they use PaaS. Within the given cloud environment, the developers can often easily switch between the operating systems and the software versions to suit their needs. That is the flexibility on PaaS. Simplicity, when the underlying infrastructure and operating system being managed by the cloud provider. Hardware and software upgrade and system patches are being handled for the developers, so that they don't need to worry about that. Ease of access. This is being a cloud based. It means that the development platform and tools are easily being accessed from anywhere in the world. Then moving to software as a service, SaaS. Here in SaaS, we have users are actually the users. There is no user who is developing the application here. Actually, everything is being offered by the cloud service provider. This is the final user at the SaaS level. There is no development. It is let's take an example of the YouTube, Twitter, or Instagram, Facebook, etc. So these are all users, and everything is being hosted in the cloud, and you just use and access these services using the thin or thick client through your mobile phone, your desktop, etc. And everything is being hosted in the cloud. So here, provider has more control. The customer actually don't have the control. In terms of the responsibility, the customer remains responsible for their data, and rest everything is being handled by the cloud service provider. Infrastructure, network, storage, OS, server, application, everything is being handled by the cloud service provider. In terms of the software as a service benefits, we have cost efficiency here. The cloud helps the customers, that cuts the cost. You don't need a system administrator who will monitor, who will configure everything, and we don't need the dedicated hardware and software. For SaaS application, the customer only needs a device to access the given application and an internet connection. In terms of licensing, that is another benefit. The customer don't need to purchase or lease a license, which is the incurring cost for them. A standardization, because by nature the cloud applications are standardized regardless of who is accessing or where they are being accessed. From an application standpoint, the standardization helps ensure the consistent experience from one user to another and make sure that all users are using the latest and greatest software version with little to no action taken by the customer. Cloud deployment models. So there are primarily four deployment models here: public, public, private, community, and hybrid cloud. So when we talk about the public, the resources, for example, the hardware, software, facilities, and staff are owned and operated by a vendor and sold, lease, or rented to anyone, offered to the public. Hence, this is named as a public cloud. In the public cloud, we have the multi-tenant environment. That means the multiple customers, worldwide, here can access this public cloud. The whole world, can access this public cloud, and the different customers, different consumers may be hosting their application within the same infrastructure. They might be using the same server through the different workloads. Few examples in the public cloud. For example, the public cloud vendors, including the Rackspace, Microsoft Azure, AWS, GCP. So these are all public cloud. When we talk about the private cloud, it means it cannot be accessed from or it cannot be accessible to anybody in the world. It is basically, it is required to protect some kind of sensitive data, right? And this public cloud, it is for very general services which are not very mission critical, but this private cloud is actually for the mission critical services which are supposed to be deployed within the private network, and should not be accessible to everybody. Therefore, the private clouds are not multi-tenant environment. There are different options here. One is a private cloud might be owned and maintained by the entity that is the sole customer. In other words, an organization might own and operate a data center that serves as the cloud environment for that organization user. Another one is a private cloud that might be a set of resources, racks, blade servers, software packages owned by the single customer, but located and maintained at the cloud's provider's data center. Here, the problem is the cloud provider might offer the physical security, some basic administrative service, and the proper utilities like power, connectivity, etc. For the customer's resources. They sometimes referred as the co-located environment. So this is a very important terminology, co-located. So this is the important term, should be remembered. Another private cloud option is where the contract with a cloud provider such that the provider offers the exclusive use of a specific resource for that the customer inside that. Otherwise, that would be a public cloud. The community cloud, a community here, the cloud features infrastructure and processing owned and operated by an affinity group. Disparate piece might be owned and controlled by individual or distinct organization, but they came together in some fashion to perform the joint tasks. So the different organizations might be working on the similar project, and they need a dedicated cloud which is not accessible to different other organization, and it is the dedicated group. So they develop some kind of community cloud. uh, Another example, maybe the cloud provider might offer like FedRAMP cloud services for use only by the US federal government customers. Any customer that is not a US federal agency will not be allowed to use this service as non-governmental entities. They are not part of this particular community. So one last is the hybrid cloud. In the hybrid cloud, this is the overall. This covers almost everything as part of the hybrid cloud. This can have community cloud, this can have public cloud, this can have private cloud, and this can have more than one cloud also. In terms of the hybrid cloud, here, um, an organization that might want to retain some private cloud resources, say their legacy production environment, which is being accessed remotely by their user, but also lease some public cloud space as well for their operations. So that is where uh, the hybrid cloud comes into the picture. Some cloud shared considerations here. Interoperability. When we talk about the interoperability, this means the applications compatible with AWS, for example, must be compatible with Azure, and this offers the ability for two or more systems to seamlessly work together by sharing the information and using that information as necessary. In cloud, the interoperability ensures that the cloud services can understand standard data format, APIs, configurations, identifications, mechanisms, so that these cloud-based applications are able to work with the organization's existing technology or even other clouds. Portability. This is the um, basically to avoid the lock-in, actually, that can help to move one cloud to another cloud without any problem. And the portability means that the service provider, underlying platform, operating system, APIs, format of data, etc. These do not present any obstacle to seamlessly moving services from one solution to another, and no lock-in at all. So lock-in means that prevent one customer to move from one cloud provider to another. So when we say the portability, it means if it is portable, if the cloud is supporting the portability, that means there is no lock-in issue with that. Reversibility is the key enabler for to reduce the vendor lock-in. So kind of related terminologies. Availability is a key pillar of the security. Usually the provider offers 99.9 percentage of availability. So how what your contract says, and what is your need. Sometimes some customers need is to have 5 times 9 availability or 7 times 9 availability. So that is the another impact. There should not be any single point of failure uh, which will impact the availability. Security is the top concern for the cloud customers. Moving to cloud increase the security capabilities to reduce the security risk, as they offer world-class security controls in the cloud. Privacy is the primary concern in the cloud due to the fact that different privacy regulations into the effect location of the actual data, data dispersion, cross-border data are the area of concern which should be covered in the contract and should be taken care of during the audits and finalizing the contract. Resiliency means the measures that the ability of a cloud provider to continue providing fully functioning services in the event of disruption. So how resilient your cloud is, what are the controls, so proper bcdr plan, redundancy, backup, etc. We need to take care during the sharing the responsibilities and finalizing the contract. Performance, the cloud computing and high performance are intertwined, I would say, because there are new emerging technologies. These are relying on cloud infrastructure needs. They needs the higher performance to contribute or to support these kind of features or functionality. Governance relates to the policies, procedures, rules, and responsibilities in terms, in place to ensure security, privacy, resiliency, and performance. So, if we have to support the security, privacy, resiliency, and performance, we need proper policies, procedures, roles, and responsibilities in any organization. So that means the governance. Governance is required at the start of any cloud migration and continues through the entire lifetime of the cloud deployment. SLAs, this is an agreement between the cloud service provider and the cloud customer that identifies the minimum level of service that must be maintained. One to keep in mind, this should be kept in mind. A few examples: availability, performance, data ownership, portability, location of data, BCDR. So these things should be taken care of while finalizing the service level agreement with any provider. Regulatory organization obligations, it is a requirement for organization to meet the governance. Failing to meet these may attract the financial penalties. Maintenance and versioning, it is important how to maintain the versioning of the documents of the software versions for the patch management system. Auditability, very important, shared responsibility, and CCSP candidate must pay close attention to understand the CSP and CSC responsibilities in terms of the auditability. The cloud customer not having access to the provider's physical infrastructure, and accordingly, auditability need to be decided to comply with any regulation. Also, the cloud provider is responsible for providing the logging and auditing capabilities to the customer, which can be used for the audit purpose. This is a very new topic which is added to CCSP. These technologies are made easily and economically available to the customer by the automation, elasticity, and the resource pooling capabilities of the cloud computing. Apart from this, if used properly, these technologies provides a lot of ease for enhancing their business models with the great security, like AI, ML, blockchain, IoT, containers, quantum computing. So there are different modules which are being added in AWS, GCP, Azure. We can see the different modules which are being supported on the different cloud providers, and these are really important for processing the data, for collecting the data from the sensors, and containers are a really easy deployment on prem and cloud, easy integration with the Kubernetes for the automation purpose, for orchestration. Quantum computing, this is emerging technology, lot of development from the tech giants to offer the computing power, that is that the normal computer cannot offer. Thanks for watching. Please subscribe, like, comments, and enable the notifications for the regular updates. Share with all who are aspiring for CCSP examination. Thanks for watching.